Yo, 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 what up? It's your boy Rob coming back at you once again with another live stream. So before we get started, you already know what to do. If you're not subscribed to the channel, make sure you hit the bell icon twice, smash the like button, and share this stream out to all of your social media followers. All right. So let's get into it. So my question for everybody, I'm not sure if you're familiar. I know if you watch my channel, you are. My question is CERN the Space Bridge? Now, you might not know what either one of those things are, but I'm going to explain it to you. All right. So I'm going to ask that question again before, a couple people get in here. So if you're watching it late or you're watching it on the lag, you already know what the question is. You already know what the discussion is. My question is CERN the Space Bridge? Now, if you don't know what either one of those things are, and if you're not into science or science fiction, this might not be the right stream for you to be in. But if you got a good imagination, if you're into science, if you're into technology, if you're into science fiction, if you're into old school cartoons, well, then you stumbled across the right place. All right. So I'm going to put a picture of the space bridge up on the screen. See that right there? There it is. That's the space bridge. Now, if you recognize that pale purple color, that pale purple color is the trademark color of the Decepticons. All right. If you all remember the Decepticons are allegedly the evil robots that the Autobots used to fight against in the battle for Cybertron from the Transformers series. I got a question for anybody that's watching this or anybody that watches this on the replay. Are you a Transformers fan? Did you, have you, do you watch Transformers? If you do, what's your favorite? My favorite is Generation 1 and the old school 1986 movie. All of this new stuff that they come out with, the Michael Bay Transformers, I'm not really feeling it. It's a little bit too much for me. You know what I'm saying? It's just not something that I'm really into. I don't like it. A little bit too much action. To me, Transformers, I grew up with it as a cartoon. It's got to kind of stay a cartoon. You know what I'm saying? It's got to kind of stay a cartoon to keep its authenticity. You know what I'm saying? Some people, I guess, if you've never been exposed to the classic Transformers of the 80s and you happen to see it in its current form, I guess it's okay, but you're missing out. All right. However, this rudimentary looking device right here on the screen, this, ladies and gentlemen, this is the space bridge. All right. Now, you might ask yourself, well, what is the space bridge? What are you talking about? The space bridge is a multifaceted device, and it had more than one purpose. The first purpose for the space bridge was that it transported stored energy called energon cubes from Earth or wherever it was located to Cybertron. I don't know how it worked. We'll watch a little video, but what it looks like is it concentrated some kind of power, some kind of energy mass transfer into a point. And then that point opened up some kind of portal, whether it was a black hole or I don't know what it could have been, but it opened up something like that. Once that thing opened up, the gravity pulled whatever was inside the space bridge up into the hole, and somehow it came out somewhere else at some calculated point. Now, that's pretty interesting. It could be a wormhole, could be teleportation. I don't know, but it was a pretty cool concept. And what's crazy is that concept now is currently being used. But let's just run it back. You remember that video about the future that we did? That video about the future that we did, is also showing that storable energy will be one of the most important industries in the future. Portable energy storage. All right. So look, the Transformers already had that on point. They had the Energon cubes. All right. So I'm going to take this off the screen and I'm going to show you guys a video of exactly how the space bridge works. All right. And I hope that they don't strike my channel for this. I doubt it because it's not that many seconds, but we will see. All right. So I'm going to put this back up here so y'all can see it. Now, I want y'all to check this out. All right. Now, you see this little device right here. On this device, it's kind of like some kind of glide, some kind of car. And it looks like it hovers over this metal part. It probably uses some kind of magnetism. It rides along that metal beam. And then it goes directly inside of the space bridge. The space bridge closes, the energy mass thing turns on and activates, the hole opens up, and then the device and the container and the person inside of it, they get sucked into the portal or the space bridge. All right, it's pretty cool. So let's take a look real quick. See, so that was pretty cool. I'm gonna run that back one more time. All right, I'm gonna run that back for you one more time so y'all can see exactly how that works. All right. So check it out. It works literally exactly how I said it did, at least according to what they show on the TV. All right. So let's check it out one more time.
We must get those cubes over the bridge before it closes.
So there it is. So that's how the space bridge works. All right. The way that the space bridge works, like I said, you go in, some kind of electromagnetic force starts to turn on. It concentrates to a point up at the top, focuses a little area that opens up. And then what ends up happening is whatever is in that tube radius that is in the space bridge gets sucked up into it. Pretty cool. Pretty cool concept, right? Now, the reason why I bring that up is because my question for everybody is, have you heard of the organization that is called CERN? All right. And the reason why I ask you if you've heard of the organization called CERN is because CERN could most definitely be on the verge of creating a technology very similar to what the Decepticons used as the space bridge. All right. So here is CERN right here. This is the CERN website. All right. And what I find the most interesting, people may or may not have noticed about this. There's a lot of symbolism, a lot of occult symbolism when it comes to CERN. If you take a look at the symbol for CERN, looks a lot like 3 6s. That's just something to keep in mind. You know what I'm saying? So now here they say on here, what is the universe made of? What is what is the nature of our universe? What is it made of? All right. So here we have this device. This is the most famous device when it comes to CERN. This is the thing that everybody associates with it. It's called the LHC. All right. The Large Hadron Collider. All right. Data taking in physics facilities is resuming. All right. So here's all of the stuff that they have at CERN. It's a pretty cool looking place, but they got a lot of weird stuff going on there. All right. One of the things that they are looking into is antimatter. And antimatter is very interesting. It's something that's very important. So what I want to do is I want to check out this antimatter part and see exactly what they're talking about here. All right. Because if you guys are familiar with black holes, hey, what's going on, Delmo? What's good with you, bro? Black holes are antimatter. All right. So let's check this out. In 1928, British physicist Paul Dirac wrote down some equation that combined quantum theory and special relativity to describe the behavior of an electron moving at relativistic speed. The equation, which won Dirac the Nobel Prize in 1933, posed a problem. Just as the equation x squared equals 4 can have two possible solutions. See that? And see, one of the things that I always talked about, at least when I was taking math classes, was how erroneous solutions, like when there's a square root under the negative, there's what's called imaginary numbers. And then there's also what's called erroneous solutions. Now, they call these erroneous solutions and imaginary numbers and say that they can't exist. However, I always believe that if there was an answer to a math problem, it may exist, but its interpretation in our nature is something that we don't understand. And apparently, that is what this goes into. It talks about the square root. It talks about the answer to the square root of a negative number. And it also talks about the negative answers to a positive square. All right. Because remember, when it comes to x equals 4, 2 times 2 or negative 2 times 2 can both equal 4. Okay. So if you take the square root of 4, the square root of 4 can be 2 or negative 2. So I want to make sure that you guys follow me. All right. You guys understand that? You guys follow me? So Dirac's equation could have two solutions, one for an electron with positive energy and one for an electron with negative energy. So in this situation, what we would assume is that we would assume x equals 2 is the positive the positron, the proton, and x equals negative 2 would equal the electron. Okay. And one for an electron with negative energy. But classical physics and common sense dictated that the energy of a particle must always be a positive number. And I find that interesting, right? Do you believe that? My question is, does that make sense to you guys? Does that make sense to you guys? Does the energy always have to be a positive number? Does energy always have to have a positive measurement? In my opinion, nah, not necessarily. You know what I'm saying? Not necessarily. So Dirac's equation could have two solutions, one for an electron with positive energy and one for an electron with negative energy. But classical physics and common sense dictated that the energy of a particle must always be a positive number. Dirac's interpretation of the equation to mean that for every particle, there exists a corresponding antiparticle, exactly matching the particle, but with opposite charge. For example, for the electron, there should be an anti-electron or a positron, identical in every way, but with a positive electric charge. The insight opened the possibility of entire galaxies and universes made of antimatter. Now, I got a question for anybody who is familiar with physics or anybody who understands any of these concepts. My question is, do you know what happens when negative matter collides with positive matter? What's up, Kenny? I don't go live that often, bro. I set my videos to show up as premieres, so it looks like I'm live, but I'm not. This is an actual live stream, though. What happens when a negative interacts with a positive? Do you guys know? What's the answer for that? If I have a electron and I have a positron and they come together, what happens? That's my question. Anybody got the answer? It's been a long time since I've taken physics, but here they go. They got the answer right here. But when matter and antimatter come into contact, they annihilate, disappearing in a flash of energy. So that means that mass disappears, the mass of the antimatter disappears, and that the energy is released as a result. And that energy that's released as a result is that exchange between mass and energy, which is important. That's one of the fundamentals of special relativity, right? Positive collide with negative, a black hole, similar, kind of. But what ends up is more like a big bang, actually, more like a big bang. Negative and positive, they come together. And see, the thing is it's the same thing, right? So if you add -1 plus plus +1, what do you get? You get 0, right? That's the same thing as annihilation, because annihilation means it's not there anymore, right? So if you combine an equal numerical amount of positive and an equal numerical amount of negative, then that means that what you have left is an annihilation, which equals 0, right? -4 plus +4 equals 0. That means that it annihilated, right? -1 plus 1 equals 0. 0 means that it annihilated, right? Everything was used up, okay? The Big Bang should have created equal amounts of matter and antimatter. So why is there far more matter than antimatter in the universe? Now I got a question. What is the evidence that there is more matter than antimatter in the universe? These are the kind of assertions in modern science that tend to boggle my mind. We're making an assumption that there is more matter than antimatter in the universe. How would we know that? That's my question. Energy cannot be destroyed. It just transforms. Exactly. And that's where we get the flash of light. We get the mass of the positron and the negatron and the electron coming together, and that flash of light is the transfer. So that energy, as they combine, it transfers from the matter, from the mass to the energy. All right. So now here it says at CERN, physicists make antimatter to study experiments. Now, don't you think that's kind of weird? Because most of the matter that's in our reality is regular matter, not antimatter, right? It's regular matter. Oh, and Kenny, that's bots over there that's doing that. As far as the censoring, it is what it is. I don't want anything happening as far as like YouTube or Twitch removing my channel. So I have bots that automatically do that when people start using ridiculous language. At CERN, physicists make the antimatter to study and experiments. Now, I got a question. Do y'all think that would be safe? Do you think that that's something we should do on a routine basis? If we don't have a lot of antimatter here on the planet, if we don't have a lot of antimatter in our near, neighborhood in the universe, is that something that we should be doing? Shouldn't we worry about how the antimatter interacts with the matter? And if we come up with antimatter and we have it stored, how do we know that it just won't randomly be bombarded with the right particle and just blow up? You've got to write in codes to avoid bots. Yeah, you got to write in codes to avoid bots. At CERN, physicists make antimatter to study and experiments. The starting point is the antiproton decelerator, which slows down antiprotons so that physicists can investigate their properties. Now, I got a question for y'all. What would an antiproton be? That's my question for y'all. What would an antiproton be? No antimatter is opening Pandora's box. Plus, put a statue of Shiva in their building. Says it all. Yeah, that's big facts. And you know what else they did? They did the death dance as the opening ceremony, which that's kind of creepy in itself, right? It's kind of weird. You know what I'm saying? So I got a question for y'all. The Higgs boson. Anybody know what the Higgs boson is? If you know what the Higgs boson is, let me know. Type it in the comments. I'm curious to see how many nerds we got in here. So here's what CERN says about it. The Higgs boson, elementary particles gain their mass from a fundamental field associated with the Higgs boson. So let's just break that down real quick. What is a fundamental field? Isn't that interesting? A fundamental field? In my opinion, a fundamental field is an area of influence. So it has to be an area around this particle. Okay. Now, if I'm not mistaken, the Higgs boson particle, that's one of the particles that they call the quote God particle. It's one of the smallest units of measurement that still has mass. So it's like a pre-photon. All right. A photon, I believe, is for the most part primarily made up of energy, and a photon does not have very much mass, if any mass at all, because a photon is what makes up light. It's the smallest unit of a light emission, smallest unit of energy. All right. So now here it says the Brout-Higgs mechanism. In the 1970s, physicists realized that there are very close ties between two of the four fundamental forces, the weak force and the electromagnetic force. The two forces can be described within the same theory, which forms the basis of the Standard Model. This unification implies that electricity, magnetism, light, and some types of radioactivity are all manifestations of a single underlying force known as the electroweak force. All right. The basic equations of unified theory correctly describe the electroweak force and its associated force-carrying particles, namely the photon. All right, see that? Namely the photon and the W and Z bosons, except for a major glitch. All right. All of these particles emerge without a mass. While this is true for the photon, we know that the W and Z have mass, nearly 100 times that of a proton. Fortunately, theorists Robert Brout and Francois Englert and Peter Higgs made a proposal that was to solve this problem, what we now call the Brout-Englert-Higgs mechanism, which gives the mass to W and Z when they interact with an invisible field, now called the Higgs field, which pervades the universe. All right. See, so check that out. If you look at that tubular area around the focal point of that particle right there, that right there is the Higgs field. All right. Does that make any sense? Just after the Big Bang, the Higgs field was zero. Now, I got a question for y'all. Why would the Higgs see some of this stuff? People always say that physics is so hard. The reason why it's so hard is because people teach it to be hard. Now, my question for y'all, I'm going to ask y'all a question. I need a little bit of participation. Why is it that just after the Big Bang, the Higgs field would be zero? Think about it. We had a Big Bang. Immediately after, there begins to have a Higgs field right after the Big Bang. Why would that happen? Think about it. The answer is so easy, it's going to make you go crazy. So that's my question, you guys. Why would there be a Higgs field immediately after the Big Bang? Okay, let me know. The Higgs field was zero, but as the universe cooled and the temperature fell below a critical value, the field grew spontaneously so that any particle interacting with it acquired a mass. The more a particle interacts with this field, the heavier it is. Particles like the photon that do not interact with it are left with no mass at all. Like all fundamental fields, a Higgs field has an associated particle, the Higgs boson. The Higgs boson is the visible manifestation of the Higgs field, rather like a wave at the surface of the sea. So that's a lot to unpack. That's a lot to unpack, but the answer to the question that I asked is still pretty easy. So my question for you guys is, why is there after the Big Bang a Higgs field? Why not before one? The stuff that I just read should make the answer to that question slightly easier. All right. So if you're watching this video on the replay and you get here, drop your answer, drop your hypothesis. Let me know what you think. All right. So I'm going to read this part one more time so y'all can answer this question again. Just after the Big Bang, the Higgs field was zero, but the universe cooled and the temperature fell below a critical value. The field grew spontaneously so that any particle interacting with it acquired mass. The more a particle interacts with this field, the heavier it is. Particles like the photon that do not interact with it are left with no mass at all. Like all fundamental fields, the Higgs field has an associated particle, the Higgs boson. The Higgs boson is the visible manifestation of the Higgs field, rather like a wave at the surface of the sea. An elusive particle. A problem for many years has been that no experiment has observed the Higgs boson to confirm the theory. See, so now they're basing this theory on things that they've never observed. Now, my question is there a fundamental issue with doing science like that? Doesn't that sound a lot like religion? So, like, what I find interesting is that when it comes to this kind of stuff, creation and, physics and the Big Bang and different things like that, at the bare basis of things, there's not really much difference. The abstract sciences are heavily based in belief, just like religion. There's some factual evidence, but when you get to the more advanced theoretical stuff, not so much. We're kind of going off of faith. We're kind of going off of what fragmented evidence has led us to, right? On July 4th of 2012, the ATLAS and CMS experiments at CERN's Large Hadron Collider announced that they had each observed a new particle in the mass region around 125 GeV. This particle is consistent with the Higgs boson, but it will take further work to determine whether it is the Higgs boson predicted by the Standard Model. All right. The Higgs boson, as proposed with the Standard Model, is the simplest manifestation of the Brout-Englert Higgs mechanism. Other types of Higgs bosons are predicted by other theories that go beyond the Standard Model. So I have a question for you guys. Reading all of this, hearing all of this, knowing all of this, what is the end game at CERN? What do you guys feel that what they're studying, what it is that they're looking at, what is the end game? What is it that they're looking to accomplish? That's my question. You guys have any idea on that? What are your thoughts? Just from what you've read thus far, what do you think? What do they plan to do with and at CERN? That's my question. You guys have any idea? You guys got any guesses for me? If you don't have any guesses, if you don't know, we got time. We can read more. You know what I'm saying? Let me know. So I don't have y'all sitting here with the dead airspace. You know what I'm saying? The Higgs boson, as proposed within the Standard Model, is the simplest manifestation of the Brout-Englert-Higgs mechanism. Other types of Higgs boson predicted by other theories go beyond the Standard Model. On October 8th, the Nobel Prize in Physics was awarded jointly to Francois Englert and Peter Higgs for the theoretical discovery of a mechanism that contributes to how our understanding of the origin of mass of subatomic particles, and which recently was confirmed through the discovery of the predicted fundamental particle by the ATLAS and CMS experiments at CERN's Large Hadron Collider. Now, I got a question, okay? What does subatomic mean? Does anybody know? Anybody got an answer for me? What does subatomic mean? If something is subatomic, what does that term mean? So right here, we have a video, all right? And I don't know if this video is like copywritten or what. I don't think it should be, but who knows, all right? So, I think I got the fair use thing running across the bottom of the screen. Yeah, I got the fair use thing running at the bottom of the screen. So I'm going to play a little bit of this video. I'm going to stop and start it. CERN endgame is to open Pandora's box for the worst. Yeah, I think so. One of the things that I think that CERN is trying to do is I think CERN is trying to create a reality printer. You guys, when I say CERN is trying to create a reality printer, do you know what I mean by that? So let's check this out and see what they talk about. The Higgs boson, back to the basics, all right? All right, so let's look at what's on the screen here real quick. Photons, the particles of light, have no mass. This allows them to fly through vacuum at the speed of light, which is 300,000 kilometers per second. Do y'all know how much that is in miles per hour? It's something that's quoted in the theory of relativity. How many miles per hour is that? CERN's endgame is to control and manipulate atoms. Once you can do that, you have great power to destroy. Absolutely. Absolutely, Delmo. I totally agree. I totally agree. And I also believe that they plan on just, one of the things that the system of illegitimacy does is that the system of illegitimacy just literally wants to speak its nonsensical reality into existence. And if they are able to manipulate subatomic matter, and if they're able to access subatomic particles as well as antimatter, then they will be able to literally legitimize the system of illegitimacy by just doing nonsense like this. It seems to be that they are attempting to bring about the book of Revelations. Yeah, it seems like it, doesn't it? Or the Apocrypha. Is anybody in here familiar with the Apocrypha? Now, what you might find interesting, Mrs. Hands Sharp, Mr. Hand Sharp. I'm sorry. Is that Mr. Shan Sharp? Is that like Shannon Sharp, or is it Miss Hands Sharp? I don't know. Hopefully, I'm not slaughtering your name. If I am, I apologize. So please forgive me. I'm not trying to be disrespectful. What they could do with this thing is create a reality printer, right? Now, you're talking about bring Mr. Shan Sharp. Okay, so yeah, so it's like Shannon Sharp, like some Miles and some Yak. You know what I'm saying? That's what's up. I like Miles and Yak too. You know what I mean? I don't like Skip Bayless, but I like the Miles and the Yak. You know what I'm saying? So what they could do is create this reality printer. And in my opinion, I think you're right. That could definitely bring about the end. Absolutely. You're on point. So let's see what else they got. So now my question is, what are these things here? If all elementary particles were massless, our universe would be very different. Now, that opens up an interesting question. Each universe, if you believe that there's multiple universes, has different fundamental laws of physics. Question: where inside of our universe do we have different fundamental laws of physics? You guys know there are places within our universe, our very universe that we live in, that actually have different laws of physics than what we follow in our current reality. Where are those places at? That's my question. We're actually pretty close to one. Do you know where that closest place is? If you know, type it in the comments. I'll go back and read it. Now remember, electrons and protons, those aren't antimatter. An electron, the antimatter version of an electron, is a positron. Okay? There's probably some electroproton version of a proton, because remember, the antimatter version has to be the exact same, except for all the values are negative. All right. So you can see there's a clear difference between a proton and an electron. Proton is larger, right? There's some force differences, right? That's one of the reasons why the electron stays outside in the valence field, right? So there's differences there. So don't mix those up. An electron and proton are not antimatter versions of each other. Remember, if an electron came within the field of a proton, if they were antimatter, energy would be released and they would annihilate. And this atom here, which this right here is a hydrogen atom, this hydrogen atom would cease to exist. All right. Now, I got another question for you guys. Why is this a hydrogen atom? I got a lot of questions for y'all. Why is that a hydrogen atom? That's a simple answer. You know what I'm saying? It could, you know, a little bit of math there. Why is that a hydrogen atom? And is that a normal hydrogen atom or is that an isotope? And if you don't know, it's perfectly fine. Just say, you know, I don't know. We'll get there. All right. So pay attention to this. No hydrogen atoms would mean no stars, no galaxy, no life as we know it. So what does that tell you? Hey, Siri Lynn, what up? They want to open other portals and manipulate matter at the subatomic level. That's facts. That's 100% facts. Now, my question is, the screen that we have up, the screen where we had this paused right here, no hydrogen atom would mean no stars, no galaxy, no life as we know it. Now, I got a question. What does that tell you about the hydrogen atom? The hydrogen atom, for the most part, shit, is pretty important then, right? The hydrogen atom seems like it's pretty important. If you can't have a star without hydrogen atoms, what does that tell you about hydrogen atoms? That's my question. I need y'all to let me know. What does that tell you about hydrogen atoms? We already know these answers that are up on the screen. No hydrogen atoms will mean no stars, no galaxies, no life as we know it. So we don't need to go into that. However, there's something else that's key that this sentence tells us. What does this sentence tell us? What are stars made out of? What are galaxies made up of? What does life require? I'll give you a hint. The word begins with an E and it ends with a Y. What is it? That's my question. What is it? guys got an answer for me? I know you guys got an answer for your boy. Energy. My man OJ, the water bearer, with the right answer. That's what's up. Absolutely. That's the facts. Now, you guys remember those videos that we did before? What is one of the emerging markets? What is one of the things that is going to be a very profitable industry in the future? What did I say the Decepticons made the space bridge for? What did the Decepticons make the space bridge for? You guys know? Y'all were here in the beginning of the video. The Decepticons made the space bridge to transport energon cubes, right? Anybody that used to watch Transformers back in the day, what do the energon cubes have in them? In the 3D, that would be electricity. Facts. Energy. Stars require energy. Stars require hydrogen atoms, right? Remember a couple live streams ago, we talked about the fusion engine that China is trying to manufacture. That takes hydrogen atoms or hydrogen ions and smashes them together. Energy is released, right? Stars require energy because stars are natural giant fusion engines, right? Galaxies are full of stars. Remember, we talked about the type 1, 2, and 3 Kardashev scales? If you guys remember what the type 1, 2, and 3 Kardashev scales are, type it in the comments. But basically, they are logarithmic elevations of civilizations based on how they utilize energy. Okay? How they utilize energies within their stellar neighborhood, basically. Okay? And life. Life is based on metabolism that utilizes cellular ATP, adenosine triphosphate, necessary to our survival. All right. So, as you can see, this stuff may sound crazy, it may sound abstract, but it has practical applications. Without a lot of this stuff, we can't survive. They're trying to create all of this stuff from the literal pixels from the quantum foam. They tell us that the sun is a mass of matter producing energy, but in reality, it's a massive energy collapsing into matter. Yeah, that's facts. That's absolutely facts. Isn't it interesting, all this stuff that they tell us? There's a reason why, quote, they tell us everything wrong. You know what I'm saying? So now check it out. After the Big Bang, all elementary particles were massless, but something happened almost immediately afterwards. You remember I asked about that question? Energy storage is the future. Fusion industry. Exactly. So my question, Siri Lynn, where do we need to be turning our sights for investment opportunities other than cryptocurrency? We already know cryptocurrency is one place. Where else do we need to be looking at? And my other question that I asked a while ago, y'all thought I forgot. After the Big Bang, all elementary particles were massless, but something happened almost immediately afterwards. What happened? What happened after the Big Bang? And how did mass start occurring? See, this resulted in some particles gaining mass. Now, my question for you guys is, what happened that caused the particles to gain mass? There was an explosion, the Big Bang happened, right? And then all of a sudden, particles started gaining mass. How did they start gaining mass? What happened immediately after the explosion? Now, see, this is what's funny, because it's common sense what happened, right? It's really common sense what happened, but in the 1960s, physicists had to propose a theory. Now, I want us to break this down. They fell in frequency. ATP is vital for humans, so-called keto diet, promoted as an alternative energy source via ketone. The body cannot rely on ketone. It needs ATP. Your thoughts? Well, the thing is that when it comes to ketones, right? Ketones are a little less efficient when it comes to delivering energy than carbohydrates. That's one of the reasons why, if you're diabetic and you have a high blood sugar, you can go into what's called a ketoacidosis shock or hyperosmotic ketosis syndrome. All right. So a lot of these diets are very weird. You know what I'm saying? That's one of the reasons why these new diets like to manipulate the carbohydrates, because the next thing that happens is that your body creates ketones. However, when your body creates ketones, one of the metabolites from a ketone is acetone, and that's not really the best thing to have circulating around in your blood. You know what I'm saying? And a lot of that also depends on how well your kidneys work and how well your liver works. And sometimes people don't really know. You know, you have a lot of people that tend to be alcoholics and then they want to go on one of these great diets. Well, guess what? You burned your kidneys out drinking, and you're not going to be able to process that ketone the same way somebody else would. Just like you might not be able to process the proteins as efficiently as somebody else would. You know what I'm saying? I think the most efficient diets are the ones that mirror a natural diet, which would be something like, you know, a little bit of meat, you know what I mean? And, you know, probably a majority of fruits and vegetables, mainly vegetables, complex carbohydrates, you know what I'm saying? Green vegetables, things like that, like vitamin rich type diets, foliage, you know what I'm saying? There's a vitamin, a B vitamin called folate, you know what I'm saying? Of course, that comes from the foliage, you know what I'm saying? But it's easy to tell how these particles get their mass. And you don't even need to be a physicist in order to understand. At the beginning of an explosion, there's a lot of motion, right? There's all kinds of stuff going on. There's light and there's energy being emitted. Whatever light and energy are being emitted inside at that central point, that's more than likely the most hot area. So there's going to be high motion in the center. And as it spreads out and cools down, the energy decreases and there's less motion, right? Because we all know when it comes to energy, energy has to do with motion and vibration. So as vibration slows, that can be interpreted as temperature decreasing, right? I should do a topic on nutrition. Yeah, I can do that. Yeah, I'll do that one of these days for sure. Actually, I had actually wanted to do a live stream about Nikola Tesla's electromagnetic diet. Nikola Tesla had a diet that he recommended. You know what I'm saying? And I found it pretty interesting. So I was like, yeah, I wouldn't mind doing a live stream about that. You know what I'm saying? Or a video about that. That'd be interesting. People need to eat better. You know what I'm saying? So as things start to cool, then there's less motion. And if there's less motion, then that means they're less energetic. And if it's less energetic, then it's transferring to mass, because mass isn't energy. Mass doesn't have motion. It's just mass. when mass is excited and it becomes excited to the maximum point, that's when mass heats up to the point to where it can become energy. So on the outer realms of the Big Bang, that stuff is already cooled because it's the farthest away from the impact point. So as it cools down, it's developing those fields. Remember, we asked a question about the fields? Pointed questions. Energy storage is an industry to be delved into. Absolutely. Absolutely. So some of the future content that you guys are going to see me talk about is energy storage, how to invest in it, how to start your own. In my opinion, it's not a bad idea for everybody to get solar panels. Look at all of the electric storms going on out west. Look at all the power outages out west. You think that if you had solar panels, you'd have to worry about that? You may. Dark Star, what up? Good to see you. How you doing? But you have to worry about it a little bit less than people who are solely using electricity. You know what I'm saying? So you see that force field that came into action immediately after the Big Bang? That force field came into action after the Big Bang because the particles were formed. And remember, what did it say in the beginning? The force fields, the particles are the visual representation of the force fields. All right. Remember, everything is a field. They always teach that everything is solid, but that's not necessarily true. Everything is a field. That's one of the reasons why in quantum theory, when you're not observing particles, they behave like a wave. But when you are observing them, they behave like a particle. There's a field. That field is what makes that wave-like activity. Now, see, it says particles that interact with this field get mass. And basically, I don't know, man. You know, this field thing is kind of theoretical. Another interpretation of this is the field could be a place that slows the energy inside of these particles down. It could be a decrease in temperature. It could be a decrease in consistency. There could be all kinds of things. There could be all kinds of properties in this field. But basically what happens is, do you see all these little dots? Once it goes into these dots, whatever was causing the energy that made them be energy out here, once they cross into this field, then they become mass. Particles that interact with this field get mass. So when they say they interact, there's some kind of process that takes place. There's some kind of exchange. There's some kind of interaction. That interaction could be cooling. That interaction could be slowing, which we all know cooling and slowing, for the most part, essentially are the same thing. OJ says it's lowering a frequency. Yeah, and lowering a frequency, if you think about it, lowering a frequency is literally the same thing as slowing and cooling, because frequency is what? Is how frequently something happens. So if it starts to slow down, right, that's the same as cooling. It's less energetic. High frequency is high energy. That's where you get your blue, your purple, you know, your indigo lights. But as you go to red, the wavelength increases. They're less energetic, right? If we are a part of the solar system, our energy does not die out, only changes, right? It either gets weaker or it gets stronger, or it transfers all the way to mass. So then you got to ask yourself the question, well, what about death? How's that work? You know what I'm saying? So now here it says you can detect a field in two ways. Here, now they're going to show where the electromagnetic field can be detected. Now, do you see this right here? It looks like this is some kind of magnet with some kind of electricity charged into it. You see this? Here's the plus, here's the minus, and there's some kind of circuit, and it looks like there's an open circuit. See, it looks like this circuit is open right here. What is this? What does this mean right here with the circuit open? What does that mean? That's a good question for you guys. What does that mean right there? You ever looked at the power button? You notice how there's a straight line in the power button? You know, there's a circle with a straight line. That straight line means that the circuit is together. Did you guys know that? That's what that circuit means. So when you see the circle and the line is like this, that means that there's a circuit where power can get through. That's why it's the power button. Okay. See how this line is connected and it's vertical like that? Now draw a circle around that. It's a power button. That's why the line is like that. Now you see the circuit is connected. Now you see when the circuit is connected, it's activated the north and south poles, which is the electromagnetic fields. You see this one, the circuit is open. That's why the off symbol is usually a circle with no line in it, because the line is the circuit. Did y'all know that? Like they literally get all of this stuff straight from basic, like rudimentary physics. Did y'all know that? If matter cannot be created or destroyed, the same would go for consciousness. You would assume, right? You would assume that. Now, my question is, let's go beyond that. Let's go beyond that assumption. If there's a world out there where there's antimatter, do you believe that conscious antimatter could be around? And if there's conscious antimatter, could that be the realms that we see when we talk about ghosts? Could that be the realm that we see when we talk about supernatural? Could it be? You know, you got to ask yourself the question, at what point do science and mythology and religion and all of these things converge? Because they do. For the most part, in my opinion, religion is an archaic misinterpretation of science, or religion is a purposeful misinterpretation of science to make sure that you just don't connect the proper dots to be able to unlock your true potential. Because, God forbid, if you unlock your true potential, well, then I guess the people who have so much power, they just end up being not so powerful anymore. They don't want that. You know what I'm saying? They definitely don't want that. So now you can see here, this electron here, as this electron travels by, it's sent on a different course. And it's sent on a different course because of what? It's interacting with this electromagnetic field. You see this electromagnetic field? Look at this. There's a y-axis here, and there's a x-axis here. And the radii of these circles represent the fields. Now, this particle is coming along here, and this field exerts some type of force, and it ends up bending like that. We got a curveball because of the electromagnetic force. This circuit is turned off, so it's uninterrupted in this trajectory. You guys understand that? You guys see that? Now here this says, or you can produce the quantum particle associated with the electromagnetic field, the photon. Now let's watch this. Now see, you guys see what I'm talking about? See right here? Look, see the on and off switch? See how the circuit is closed now? When the circuit is closed, then that means that you can get the electricity because it's able to travel through here. It's just like a door. Except for with electricity, it works opposite. The door has to be closed. The circuit has to be closed, right? When the door is closed, the wall is connected. So that means if you're driving or moving through the walls, then you can get to where you need to go. If the door is open, then the walls are no longer connected. There's no connection there, and you stop where the connection ends. That's how particles work. That's how electricity works. Does that make sense? Let me know if that makes sense. Now, but here it says you cannot manipulate the omnipresent Higgs field. So take a wild guess what CERN is trying to manipulate. You guys know how this goes. Anything that somebody says you can't do, guess who tries to say, we're smarter than you, we can do it. So take a wild guess what CERN is going to try to do. This is what they're trying to do. They're trying to manipulate the omnipresent Higgs field. Now, see, check this out. To observe it, we must produce its quantum particle, the Higgs boson, by colliding particles at high energies. Now, I got a question for you guys. What is the implications of this? You cannot manipulate the omnipresent Higgs field. Now, remember, in order to interact with a field, you have to be able to manipulate the particle associated with the field. So in order to manipulate the particle associated with the field, the first thing that they have to do is they have to find and locate Higgs boson particles. Once they find and manipulate Higgs boson particles, they then have to smash them together. Once they smash them together, what happens? Not only will you be able to observe what goes on with a Higgs boson particle, the Higgs boson field could possibly be manipulated. The Higgs boson field, for the most part, is an interpretation of quantum foam. It's an interpretation of space-time continuum. That literally means we're knocking things into each other, basically to create what? A black hole, a tear in reality. That make you feel comfortable? You think you sleep better at night tonight? Nikola Tesla, if you wish to understand the universe, think in terms of energy, frequency, and vibration. And Nikola Tesla was correct. That's facts. I totally agree with Tesla on that. Tesla was a white man who suffered from the system of illegitimacy, unfortunately. Now, see, this is what they're doing. Now, do you see this right here? Look at this. Using accelerators such as the Large Hadron Collider. What do y'all see right here? What do you all see right here? What is this? Look at this pattern right here on this map. Y'all can tell that this is a map, right? What is that? This looks like a giant number 6, doesn't it? Remember I told y'all that CERN has those 3 6s that make up the symbol? Something to think about. So these are the accelerators here. So now, like most particles in nature, the Higgs boson is unstable. It immediately transforms into lighter particles. So the Higgs boson, when agitated, we don't know exactly how it will behave. Apparently, what can happen is it can break into 4 electrons, or it can break into 2 photons. Now, my question is, do you think that there's implications with all of those? So you guys understand what's going on here, right? When they're smashing these Higgs boson particles together, these are miniature Big Bangs. These are controlled, well, allegedly controlled Big Bangs. What are the implications of that, in you guys' opinion? What could result from that? What could result from just repeatedly, just repeatedly duplicating the Big Bang right here on Earth? We can't even say that the Big Bang took place in the vacuum of space, because the Big Bang residue is the vacuum of space. So we don't even know theoretically where the hell the Big Bang took place, but we're doing it right here on Earth inside of an already expanding Big Bang residue. What are the implications of that? So after all of these collisions of particles, Atlas and CMS observed a new particle whose properties were consistent with the Higgs boson. So again, I got to ask you all the same question. What's up, Saint? They are also messing with controlling the weather. Yeah, they got what do you call that? HARP, that they lied and said that they closed down, and then turns out they just got a $30 million grant. So let's go back to this one real quick. Why is the Higgs field special? You guys remember why the Higgs field is special? So this is interesting right here. This is important. There's two kinds of fields in nature. All right. Vector fields, like the wind, they have magnitude and direction. So that means that the vector field is a two-dimensional field, right? There's two dimensions, magnitude and direction. Now I find it interesting, that the size of the field isn't listed, as a dimension. And then scalar fields like temperature are only defined by the magnitude. All right. So this basically is the density. Okay. Quantum particles associated with the vector field have an intrinsic spatial orientation known as a quantum spin. All right. So remember, what is a vector field? The vector field has magnitude and direction. The scalar field has only magnitude. So quantum particles associated with a vector field have an intrinsic spatial orientation, and this is known as a quantum spin. It says the Higgs field is the first scalar quantum field we found, and the Higgs boson is the first elementary scalar particle ever seen. It has no quantum spin. So remember, you can't have spin in a vector field where there's no direction. In the scalar field, there's only magnitude. That's why over here, there's no spin. So now that brings us to some interesting implications, right? Because when we're dealing with scalar fields, now we're dealing with laws of physics that are somewhat inconsistent with what we see at our scale of existence. So again, I got to ask the same question. What does messing with this kind of stuff, what are the implications of it? So now here it says, by measuring its mass and studying its various modes of production and transformation, its discovery, the Higgs boson, has cemented its place. In the standard model of particle physics. So remember, with this standard model of particle physics, what these people are trying to do is they're trying to create a reality printer. In my opinion, that's the end goal. Anything else that comes out of it is just an added bonus for them. It has become invaluable in the search for new physics phenomena. These right here, these subatomic particles right here, these are the building blocks of reality. We're not talking about the building blocks of, a person or DNA. We're literally talking about the fibers of the universe. And they're trying to take this apart, deconstruct it, manipulate it. What do you guys think about that? What's the implications of that? I thought that was a pretty cool video. But then again, I'm a nerd. But I like that kind of stuff. So that right there is the Higgs boson. All right. So we've explored the Higgs boson. All right. The next thing I think we should look at is the antiproton decelerator. You guys want to check out the antiproton decelerator? You guys know what that is? If it's a decelerator, then that sounds like it's slowing something down, right? And usually what is slowing down usually comes, after the name. So that means it's probably slowing down antiprotons, right? And remember, what kind of charge does an antiproton have? If we're dealing with an antiproton, what kind of charge is associated with an antiproton? That's my question. The antiproton decelerator. The antiproton decelerator is a unique machine that produces low energy antiprotons for studies of antimatter and creates anti-atoms. Now that's interesting. What is an anti-atom? What would an anti-atom look like? You guys know the answers to all of this because we talked about it. Very easy to convert these kind of things, right? So first question, what is the charge? What is the electrical charge of an antiproton? And describe an anti-atom. A proton beam coming from the proton synchrotron is fired onto a block of metal. These collisions create a multitude of secondary particles, including lots of antiprotons. These antiprotons have too much energy to be useful for making anti-atoms. They also have different energies and move randomly in all directions. What does that tell you about what kind of field that they can be in? They can only be in a vector field, right? because a scalar field only has magnitude. It doesn't have direction. So they can only be in a vector field because a vector field has direction and magnitude, right? So you got to pay attention to all this stuff. These antiprotons have too much energy to be useful for making anti-atoms. They also have different energies and move randomly in all directions. The job of the AD is to tame these unruly particles and turn them into a useful low-energy beam that can be used to create and produce antimatter. Tame this unruly beam. Tame these unruly particles. That sound familiar, doesn't it? That sound familiar to anybody? These protons, which emerge from the block at diverging angles, are focused before they reach the AD. Only a fraction of them have the right energy to be injected into and stored in the AD. The AD is a ring composed of bending and focusing magnets that keep the antiprotons on the same track, while strong electric fields slow them down. The spread in the energy of the antiprotons and their deviation from their track is reduced by a technique known as, what did I tell you guys? Cooling. If you were to describe cooling, what does cooling do? Cooling slows down the vibration. Cooling slows down the frequency, right? Antiprotons are subjected to several cycles of cooling and deceleration until they are slowed down to around a tenth of a light speed. A newer deceleration ring, Elena, which is a low energy antiproton, is now coupled with the AD. This synchrotron, with the circumference of 30 meters, slows the antiprotons even more, reducing their energy by a factor of 50 from 5.3 MeV to just 0.1 MeV. An electron cooling system also increases the beam density. With Elena, the number of antiprotons can be trapped increases by a factor of 10 to 100. Now, what is 10 to 100? That's a pretty big logarithmic jump, isn't it? Because remember, when we're dealing with logarithms, we jump by a base of 10. Improving the efficiency of the experiments and paving the way for new experiments. Installed in 2000, the AD made headlines in 2002 when large numbers of anti-hydrogen atoms were produced for the first time. Initial attempts were made to store anti-atoms for long enough time to be able to measure their characteristics. In 2011, an experiment announced it had produced and trapped anti-hydrogen atoms for 16 minutes, which was long enough to be able to study their properties in detail. The following year, the first measurement of the anti-hydrogen spectrum was published. Since 2010, the AD experiments have published numerous measurements of antimatter characteristics, comparing them to those of matter. Currently, the AD and Elena serve several experiments that are studying antimatter and its properties. AEGIS alpha, ASCUSA, base, G-bar, whereas ATRAP and ACE now have completed their experiments. Now, my question is, that's a lot. That's the proton decelerator. My question is, what do y'all think about all that? How do you guys feel about that? That's what CERN is doing, all right? CERN is trying to manipulate subatomic particles to do whatever they wish with. They could possibly tear open the fabrics of reality while you're at a family reunion, while you're on the toilet. Reality could just collapse. My question is, who would be liable for it? The implications us cooling of the planet subatomically. Yeah, Absolutely, Sari Lynn, and that's a scary thought. You know what I find interesting is that these organizations just undertake these kind of projects, and whose permission do they ask? Where's the ethics committee? So this is the famous Large Hadron Collider. This is the thing that everybody associates with CERN. The Large Hadron Collider. Before we get into this part, I have a question. Do you guys think that other things exist within those fields? There's a plan to bring in a conscious entity and give it a body, and that body will be technology. Are you talking about something like some antichrist intelligence, huh? I swear that word subatomically was said by Jizza in the Wu-Tang Triumph song. I know Inspector Deck said at the beginning, abomatomically, like Socrates' philosophies and hypotheses. I forget what else he said after that. Lyrically perform armed robbery, flee with the lottery. Possibly they spotted me. Yeah, that song Triumph, man. They killed that. That was my cut back in the day. Speaking of the Wu-Tang Clan, make sure y'all check out my video because a Wu-Tang Clan affiliate that was actually friends with Ghostface was falsely accused by the New York state government of a murder. They put him in jail. He served 23 years of a sentence. And guess what? They got the wrong guy. And, it's just okay. Oh, listen, sorry about that. So make sure y'all look for that video, all right? Because it's up. And if y'all not subscribed to my other channel, make sure y'all hit up Blacklight Revelations 1, all right? So let's check out this Large Hadron Collider. No financial compensation. Disgusting. Yeah, man, it's ridiculous. How do you just lock somebody up and that's just the end of it? I'm just going to lock you up and that's just it. You're done. Seriously? The Large Hadron Collider. The Large Hadron Collider is the world's largest and most powerful particle accelerator. It first started up on September 10th of 2008 and remains the latest addition to CERN's accelerator complex. The LHC consists of a 27-kilometer ring of superconducting magnets with a number of accelerating structures to boost the energy of the particles along the way. Now I got a question. You guys think that the people who are working with this thing probably, in the next 10 to 20 years, maybe even 20 to 30 years, are going to be experiencing some insane exotic form of cancer? Yeah, I think so. Inside the accelerator, two high-energy particle beams travel at close to the speed of light before they are made to collide. The beams travel in opposite directions in separate pipe beams, two tubes kept at ultra-high vacuum. They are guided around the accelerator by a strong magnetic field maintained by superconducting electromagnets. The electromagnets are built from coils of special electric cable that operates in a superconducting state, efficiently conducting electricity without resistance or loss of energy. This requires chilling the magnets to negative 271.3 degrees Celsius, a temperature colder than outer space. Isn't that interesting? Isn't that interesting? So we're just going to chill this thing to a temperature colder than outer space. And that's supposed to hold up in our reality on our planet, in our container somehow, and not affect anything else. We've already talked about how everything is based on fields, which means that everything is collected or connected. It's all good. For this reason, much of the accelerator is connected to a distribution system of liquid helium, which cools the magnets, as well as to other supply services. Thousands of magnets of different varieties and sizes are used to direct the beams around the accelerator. These include 1,232 dipole magnets, 15 meters in length, which bend the beams, and 392 quadruple magnets, each 5 to 7 meters long, which focus the beams. Just prior to the collision, another type of magnet is used to squeeze the particles closer together to increase the chances of collisions. The particles are so tiny that the task of making them collide is akin to firing two needles at 10 kilometers apart with such precision that they meet halfway. All the controls for the accelerator, its services, and technical infrastructure are housed under one roof at the CERN Control Center. From here, all the beams inside the LHC are meant to collide at 4 locations around the accelerator ring, corresponding to the position of 4 particle detectors: Atlas, CMS, Alice, and LHCb. All right. So, ladies and gentlemen, my question for you is, what do you guys think about all of that? It's a lot, right? So that's interesting, right? So I have to ask you guys, is CERN going to be the space bridge? Is that how that's going to work? Are they going to create a space bridge using CERN? Or if you guys recall, you guys remember that thing? What is that thing right there? You guys remember this? What is that stuff, that liquidy stuff on the inside of that? Isn't it interesting how these movies always come up with this stuff, and then this man, this stuff that they put on the movies is very accurate. Yeah, it's Stargate. Exactly, Delmo. Stargate. So if we're able to manipulate the fundamental fields, do you think that they could create a Stargate? What would a Stargate do? What would the purpose of one be? What would the benefit of being able to do that? What would it do? Now I got a question. They came out with that movie Stargate, right? But did you all know that the United States military had a project? And that project happened before the movie. It was called the Stargate Project. Time travel to other dimensions. Yeah, absolutely. What would be the purpose of time travel? Do you think anybody would manipulate time? I do. Matter of fact, I know they would. And I know exactly who would do it. So I have a question, as always, because I like asking you guys questions. What is the Stargate Project? Isn't that interesting that they decided to name a movie after Stargate? And they did indeed name it after Stargate, because as you can see here, the film came out in 1994. This the code name was established in 1991, and the secret U.S. Army unit was established in 1978. So my question is, what do y'all think about this? The United States has been doing some shady, illegitimate business for a long, long time. But remember, we the heroes. We good, right? Stargate Project, not to be confused with Stargate, a 1994 film. The Stargate Project was the 1991 code name for a secret U.S. Army unit established in 1978 at Fort Meade, Maryland, by the Defense Intelligence Agency and the SRI International, which is a California contractor. The United States is known for doing dirty business with private companies to investigate the potential for psychic phenomena in military and domestic intelligence applications. To investigate the potential for psychic phenomena in military and domestic intelligence applications. That implies that they have some knowledge that this stuff exists, correct? What does this imply? What does this tell you? This is my question. What does this say? What are they up to? The project and its precursors and sister projects originally went by various code names: Gondola Wish, Stargate, Grill Flame, Center Lane, Project CF, Sunstreak, Scanate, until 1991, when they were consolidated and rechristened as the Stargate Project. Now I got a question. Why would the military be investigating psychic phenomena? Why would they be investigating that? Why is that significant? Why is that important? Would you investigate psychic phenomena? Would you waste your time with that? Stargate project work primarily involved remote viewing, the purported ability to psychically see events, sights, or information from a great distance. If you could manipulate fields and you could control it somehow, do you think that would enhance somebody's ability who already has the ability to remote view? My question is, have you guys ever heard of remote viewing? Because that's not a new concept. If you guys have heard of remote viewing, let me know. If you haven't, also let me know, okay? The project was overseen until about 1987 by Lieutenant Frederick Holmes, also known as Skip Atwater, and an aide and a psychic headhunter to Major General Albert Stablebine, and later president of the Monroe Institute. The unit was small scale, comprising of about 15 to 20 individuals, and was run out of an old, leaky wooden barracks. The Stargate project was terminated and declassified in 1995 after a CIA report concluded that it was never useful in any intelligence operation. And we know that in a system of illegitimacy, if the CIA said that something was never useful in any intelligence operation, then that means that it's one of the number one things that they're currently using. I've done it twice, not sure how. It was trippy. Yeah, that's interesting. I'm sure. What remote viewing is when you concentrate and basically you can look into wherever it is that you look into and you can see something that's going on somewhere else. I think it always happens to a lot of people. We just don't know how to control it. Sometimes you could have a vision, or sometimes you get that weird feeling that something is going on. So you got to call somebody you love to make sure that they're okay. And then, that person's like, yeah, I tripped and fell, hurt myself or whatever. All of these abilities are things, in my opinion, that we have been deprogrammed from. My Stargate film came out in 94 and the files were declassified in 95. Coincidence? Right. Nothing is ever a coincidence. One of the things that I'm going to start doing with the members only tabs is I'm going to start doing playlists. I'm going to start doing member only playlists of important books that I think are interesting. One of the books that I plan on doing is Behold a Pale Horse. And Behold a Pale Horse, that's basically what Bill Cooper says. Basically, nothing is a coincidence. You know what I'm saying? Information provided by the program was vague and included irrelevant and erroneous data, and there was a reason to suspect that its project managers had changed the reports so they would fit background cues. The program was featured in the 2004 book and the 2009 film, both titled The Men Who Stare at Goats, although neither mentions it by name. Now you got to ask yourself the question, how the hell did they know that's what it was that they were talking about if it didn't mention their name? How's that work? Does that make any sense? I don't know if you guys are aware of this, but the movie E.T. was allegedly about some alleged alien that the United States government may or may not have come in contact with called EB. All right. That could have happened. I don't know, allegedly. Right. So now we went through the Stargate project. All right. So my question is, one of the things that they could use this kind of stuff for is travel. If you can manipulate the fields and if you can manipulate the fabric of reality, then that means that you can change the shape of it. And if you can change the shape of it, then you can bring 2 points closer to each other and shorten the distance in between those points, kind of like what they theorize a black hole or a wormhole could do. Correct? I've watched that movie, Men Who Stare at Goats, starring George Clooney. Was it any good? I never heard of it. That's an interesting title. Men Who Stare at Goats. So my question now, what we're talking about here is quantum teleportation. What do you guys think about quantum teleportation? This is interesting, right? You don't think that they're doing some kind of stuff, experimenting around and trying to see if they can do this kind of stuff at CERN too? Yeah, I bet you they are. So let's check out quantum teleportation and see exactly what they're doing. Because remember, one of the most important new and emerging industries is fast transportation. I still got to put the stuff together to do the live streams and the videos on the hypersonic planes, but they plan on doing hypersonic planes. They plan on doing underground transportation. We're going to be talking about this kind of stuff because this is what I'm talking about. We need to be looking into these kind of projects, not only to come up with our own discoveries, but also to be able to corner these markets and force dominance in these markets and force the world to have to succumb to anything that we need. Period. Because keep begging people that hate you for stuff and they're just going to keep feeding you poison. The only way to make sure that that doesn't happen is you take control yourself and maintain that power. Beam me up, Scott. Star Trek. Big facts. Quantum teleportation, separating science fact from science fiction. It goes without saying that many terms and concepts from science, and particularly physics, find themselves transported from the pages of journals and reports to the comic book page or the TV screen, albeit intrinsically charged. Quantum teleportation is an interesting example of this process working in reverse. Though physicist and information theories, Clark Bennett took the term teleportation from popular culture. Quantum teleportation is radically different than the process used by the crew of the Enterprise to beam down to an alien vista. But despite this, that image of Kirk, Spock, Bones, and a crew of hapless red shirts traveling down to the surface of a planet and back, albeit minus several of the red shirts, is so ubiquitous that it's hard for even professional physicists to escape. Of course, I think Star Trek, where people and things are being beamed up, Ulf Linhart from the Department of Physics of Complex Systems at the Weizmann Institute of Science, tells me when I ask him what the word teleportation means to him. Leon Hart is no stranger to quantum teleportation either. He is renowned for his work in quantum optics, one of the fields in which quantum teleportation is explored. In fact, it's no exaggeration to say he wrote the book on it. This ubiquity of the pop culture interpretation of teleportation is a special kind of hindrance when it comes to understanding of quantum teleportation, as the two concepts are so radically different. Now, my question is, with what we know about CERN, do you think studying what CERN involves can help to make this possible, or no? That's my question for you guys. The first and most radical difference, you won't be using quantum teleportation to beam to the surface of an alien world or down to the local shops anytime soon. This isn't because quantum teleportation isn't up and running. We've had the technology in operation since the mid-90s. It's because quantum teleportation has nothing to do with the transit of matter. Mind over matter. How quantum teleportation shifts information. Doesn't that sound a lot like Project Stargate? Now we're moving into the realm of moving information. It went from just teleporting objects to now the teleportation of information. Isn't that what we do now currently with the internet? We teleport information across wires, superconductors, transmissions, frequencies, airwaves. Something to think about. The idea of being able to instantly or almost instantly relocate matter from one location to another was granted by the name teleportation by a purveyor of the weird Charles Fort in his 1931 book, Lo. But despite this, the idea existed for some time before this. Now, I got a question. All right, I have a serious question for you guys that I need the answer to. When it comes down to the whole idea of the remote viewing, is that a form of teleportation? Is that a form of being somewhere without being there? How's that work? Many early examples of teleportation were unsurprisingly described as being magical in nature. But with the advent of Industrial Revolution, remarkable tales of intrigue and suspense began to move away from supernatural explanations to ones of science, albeit more credible in nature. The first example of matter being transported instantaneously from one location to another being performed scientifically occurred in an 1897 novel. In Fred T. Jane's To Venus in 5 Seconds, an account of the strange disappearance of Thomas Plummer, pillmaker, the titular hero is transported from a pleasant summer house, albeit filled with strange machinery, to the planet Venus, where he encounters warring locals and some other displaced Brits. This is the first recorded example of scientific equipment used to transport a hero to the surface of an alien world in fiction, a function which will, of course, become the most infamous use for teleportation. All right. So this article here is quite long, but you all get the drift. And I may just do a video specifically on this article. All right. And if it turns out kind of long, I'll run it in Premiere format. Its conscious teleportation could also send information through time to your other selves. Exactly. That would have to do with interaction with parallel universes. That would have to do with being able to interact with your parallel doppelgangers, which, if we're beginning to understand how to manipulate these vector and scalar fields, that means that it's possible that we could just tear open pieces of reality and walk inside and out. But you got to ask yourself the question, what would happen if you interacted with a doppelganger? If you interacted with the anti-you, it would annihilate and energy would be released, right? So you got to ask yourself a question. Is death an actual interaction with the you and the anti-you, and the energy is your soul that's released? Is that a valid question? Is that something reasonable to ask? Watch the new Loki show. I used to read the Thor comic books a long time ago, back in the day, before they started messing Marvel up. I know about Loki. Thor was never really my thing, though. I never really was a big fan of Thor. I was always a big Silver Surfer fan. I'm kind of irritated at what they did with the Infinity War and the Infinity Gauntlet, and they took the story from Silver Surfer and gave it to the Avengers. I was never a big Avengers fan. I like some Avengers bad guys. Like, I always liked Ultron. They didn't do Ultron right. You know what I'm saying? Conscious is out of this world. Be interesting what materials they are using to achieve this. I bet many are from the continent of Africa. You know, more than likely all of them are from the continent of Africa. And I guarantee you ain't no Africans making any money off of it. So let me ask you guys this. Would you guys like me to do a separate, shorter video on this entire thing of quantum teleportation? Because I will. You know, we read the article, ask a couple questions, run it in Premiere format, have a good time. And the fact that Marvel has the whole multiverse in quantum time. Heasting. Yeah, no, that's facts, bro. I remember the Age of Apocalypse story. If you got time. Yeah, okay, cool. Yeah, I'll do it. I'll probably have it run in the next couple of days, but I'll get it recorded by the end of the day. The Age of Apocalypse story was pretty cool. But I like the original Infinity War with Magnus. You guys remember Magnus? Magnus was the anti-Adam Warlock. See, like, I don't understand how you can have the Infinity Gauntlet and you can have the Infinity War and all that stuff, and you ain't got no Adam Warlock. You need all those Silver Surfer characters. You know what I'm saying? That kind of made me upset. So the reason why I wanted to dive into teleportation a little bit was because I feel that teleportation is relevant to what we were talking about. And one of the reasons why I feel that it was relevant to what we were talking about is because there was something that was done called the Philadelphia experiment. Now, my question for everybody that's here is, are you aware of the Philadelphia experiment? If you are, give me a brief description of what it is. If you're not, let's dive into it. All right. This right here, ladies and gentlemen, is the Philadelphia experiment. Okay. Now, allegedly, this is something that allegedly happened. My question is, what are those allegations? Do you guys know what allegedly happens? Yes, I've seen the film Philadelphia Experiment. Okay, that's what's up, Delmo. Yeah, so OJ, you know what it is. All right, that's what's up. The Philadelphia Experiment is an alleged military experiment supposed to have been carried out by the U.S. Navy at the Philadelphia Navy Shipyard in Philadelphia, Pennsylvania, sometime around October 28th in 1943. The U.S. Navy destroyer escort, USS Eldridge, was claimed to have been rendered invisible to enemy devices. Now, this allegedly happened in 1943. So that tells you where the alleged technology was back in 1943. U.S. Navy wanted to make ships invisible, but went wrong and created a time warp. Now, can you imagine what would happen? Now, just imagine, just wait. Just imagine what's about to happen with CERN. It was an experiment where they tried to phase a ship through subspace. Then all of the people in the ship ended up getting fused with it as a combined into one object. Now, isn't that interesting? The story first appeared in 1955 in the Letters of Unknown Origin sent to UFO writer Morris K. Jessup. It is widely understood to be a hoax. The U.S. Navy maintains that no such experiment was ever conducted, that the details of the story contradict well-established facts about the USS Eldridge, and that alleged claims do not conform to known physical laws. Well, we already have CERN, who's already operating outside of known physical laws. So why are we expecting known physical laws to, have anything to do with unknown and unexplainable phenomena? That's the whole thing about unexplainable phenomena. It's unexplainable, right? In 1955, the Office of Naval Research received an anonymous package containing a copy of The Case for the UFO, Unidentified Flying Objects, written by Morris K. Jessup. The book was filled with handwritten notes commenting on Jessup's ideas about the propulsion for flying saucers. These annotations generally discussed alien races and expressed concern that Jessup was too close to discovering their technology. The notes refer to various incidents that supposedly verify their claims, including an alleged force field invisibility. Now I got a question. If you guys watch any popular movies that have extraterrestrials or aliens, what aliens had this kind of technology where they could kind of just turn off being visually detected? You guys remember? Who had that? Who from science fiction had that? Jessup was later contacted by Carl M. Allen using his given name as well as Carlos Miguel Allende. Allen's first letter to Jessup regarding levitation has never been published. A second letter, received in January of 1956, warned Jessup not to investigate levitation of unidentified flying objects. Allen claimed that the underlying scientific principle was secretly discovered by Albert Einstein in the 1920s during his work on a unified field theory. See? So the reason why I want to bring this up is because these field theories, they knew about all of these theories. They knew about all of this stuff way back in the 1920s. So my question for you guys is, where do you think that the technology is today? According to Allen, Einstein believed the research was too dangerous to publish, but a scientist named Franklin Reno provided similar findings for an experiment at Philadelphia Naval Shipyard in October of 1943. Allen claimed to have witnessed this experiment while serving aboard the SS Andrew Furuseth. In his account, a destroyer escort was successfully made invisible, but the ship inexplicably teleported to Norfolk, Virginia for several minutes, then reappeared in the Philadelphia yard. The ship's crew was supposed to have suffered various side effects, including insanity, intangibility, and being frozen in place. Now, that's interesting about the being frozen in place part. All that other stuff is kind of crazy, but the being frozen in place part is very interesting. Because if you guys understand how the event horizon works of a black hole, part of the event horizon has to do with spaghettification. And at the point in a small black hole where you become spaghettified, you end up being stuck in place, at least to the outside observer. Star Trek, the aliens with the funny forehead. Forgot the name. Was that the Cleons? I think that was the Cleons. Jessup wrote back to Allen requesting more information to collaborate his story. In response, Allen suggested that Jessup secure the services of a hypnotist so that Allen's precise memories of the experiment and other details could be recovered through hypnosis. Allen made several references to Philadelphia newspaper articles that supposedly covered the incident, which have never been positively identified. In 1957, Jessup was invited to the Office of Naval Research, where he was shown the annotated copy of his book. Jessup identified several annotations in which the handwriting and content resembled the letters he received from Allen. Two officers at ONR, Captain Sidney Sherby and Commander George W. Hoover, took a personal interest in the matter. Hoover later explained that his duties as a special projects officer required him to investigate many publications and that he ultimately found nothing of substance in the alleged invisibility experiment. So now what that means is that he definitely found something that means something. That's what that means, right? Can we all agree on that? Anytime the illegitimate government says that they found nothing of interest, that means that they're very interested, because that's just what they do, right? Hoover discussed the annotations with Austin N. Stanton, president of Vero Manufacturing Company, during meetings about Vero's contract work for ONR. Stanton became so interested that Vero offered to produce a limited edition of Jessup's book, accompanied by the annotations and Allen's letters for further review. The resulting work came to be known as the Vero edition. The anonymous introduction to the Vero edition concludes that the annotations were written by three distinct individuals, identified as Mr. A, Mr. B, and Jimmy. However, in 1969, Allen claimed the authorship of all the annotations. Jessup tried to publish more books on the subject of UFOs, but was unsuccessful, losing his publisher and experiencing a succession of downturns in his personal life, led him to take his own life in Florida on April 30th of 1959. Well, we all know that means that this dude was more than likely canceled by the government. My question for you guys, what do you think about all this? Did you enjoy the live stream? We talked about some heavy stuff, some pretty complicated topics. You know what I'm saying? And guess what? We'll be talking about some more complicated topics in the near future. So the next live stream that I do, ladies and gentlemen, it will probably be a Tales from the Cryptocurrency episode. But your boy is going to be out of town starting next Wednesday. So there probably won't be too much content put up. That's one of the reasons why I'm trying to get out as much as I can right now and schedule some premieres. All right. So if you guys can, y'all have plenty of time to catch up on the, on the past content. You know what I mean? I enjoyed this one, honestly. You enjoy them all, Saint. You act like you don't, but you do. You know what I'm saying? And that's okay. Sometimes, that happens. It's all good. You know what I mean? So the next live stream that I do, which will probably be in about, that depends, might be 2 weeks. I might try to mess around and get it done tomorrow if I got time. Tales from the cryptocurrency, because there's a lot of stuff going on with crypto. So I want to keep you all up to date on that. And I got a couple videos that I'm going to try to drop. And then we got a couple premieres that'll be scheduled. And I'm not sure if me and Izzy will be able to do the podcast on Wednesday on Blacklight Revelations 1, but we're going to for sure try to. I think we should be able to. It's just a matter of getting everything together, because we're going to have to do it. I'm going to be in a remote location because I'm not going to be at the lab. So we're going to have to figure that out. But we will get it. And if not, we will do an extravaganza when I get back. All right. So I hope you guys enjoyed that. All right. Make sure you are on the lookout for the video about quantum teleportation. I'm always open to learn something new. You told me about woke origin. I didn't know you didn't know what the woke origin was. Yeah, that's the woke origin, bro. It's crazy. They don't tell a lot of stuff in the news. That's why it's important to always look at things from other perspectives, even if you don't agree with them necessarily. At least being open-minded about stuff, that's real important for everybody. You know what I'm saying? So with that being said, ladies and gentlemen, I appreciate everybody that was in here. My man Delmo, my man OJ. I don't think I've ever seen you in the live streams before, but it was good to see you. You know what I'm saying? Sarah Lynn, you know, you always around. Appreciate it. Saint. All right. And I will catch you all on the next video. All right. Peace.